Hey everyone, and welcome to our masterclass on alloys. I'm your chemistry tutor, and today we're going to make sure you can tackle any SPM question on this topic with total confidence. Ready? Let's do this.
But first, before we dive deep into the science, let's get you geared up. Your #1 tool is MCQ Seriously, active learning is the secret sauce. You can practice thousands of questions for free. Go ahead, scan the code or type in the address. It's time to practice what we're about to preach.
So, what's our game plan today? First, we'll lay the foundation. What's the big deal with pure metals versus alloys? Then, we'll meet the alloy all-stars, the ones you absolutely have to know. After that, we'll get strategic and decode actual SPM questions, and we'll wrap it all up with the ultimate cheat sheet for your revision. Let's get into it.
All right, Section 1, Pure Metals versus Alloys. This is where it all begins. We're going to get to the bottom of a really simple question. Why do we bother mixing elements together in the first place? Why not just use pure metals for everything?
So let's start with the official definition. What is an alloy? Well, think of it like a recipe. You take a main ingredient, which is a metal, and then you mix in some other elements to create something brand new with totally different properties. And that leads us straight to the million-dollar question. Why does this simple act of mixing make alloys so much stronger, so much more useful than the pure metals they started as? The answer, my friends, is all about what's happening at a level you can't even see, the atomic level.
To get this, I want you to imagine a pure metal as a perfect stack of identical billiard balls. See how they're all the same size? They're arranged in these really neat, orderly layers. Now, if you give them a push, what happens? The layers just slide over each other super easily. This is why pure metals, like pure gold or copper, are actually quite soft.
Now let's make our alloy. We're going to throw some different sized tennis balls into our stack of billiard balls. These are our foreign atoms. Look at that! They completely disrupt that perfect, neat structure. The layers aren't smooth anymore. So when you apply a force now, guess what? The layers get stuck. They can't slide past each other. And that right there is why alloys are so much harder and stronger.
So this table sums up the key differences you need to know. Compared to their pure metal parents, alloys are generally shinier, way more resistant to things like rust, and of course, they are much, much harder. And it all goes back to that messy, disrupted atomic structure.
Okay, now that you understand the fundamental science, let's move on to Section 2. It's time to meet the alloy all-stars. These are the big names you are guaranteed to see on your exam, so listen up.
First up, we have brass. This is a classic combo of about 70% copper and 30% zinc. It's strong and shiny, sure, but its real claim to fame is its amazing acoustic properties. That bright, beautiful sound from a trumpet, that's brass. You'll also find it in your keys and doorknobs.
Next is its close cousin, bronze. This time, it's copper mixed with tin. Bronze is legendary for its durability. Think about it. We use it for medals, massive monuments, and trophies. Stuff that's meant to last forever. There's a reason we call it the Bronze Age.
Now let's talk high-tech with Duralumin. It's mostly aluminum, which makes it incredibly lightweight, but with other metals mixed in to make it super strong. It's the perfect combination for things that need to be light but tough, like aeroplane bodies and professional racing bikes. It was actually a military secret back in World War I.
Of course, we have to talk about steel. This is the workhorse alloy of the modern world. It's almost all iron, but with a tiny, tiny amount of carbon added. But that little bit of carbon is the secret sauce. It makes the iron ridiculously harder and stronger, which is why we use it to build, well, pretty much everything. So how do you make the ultimate steel? You make it stainless. And you do that by adding chromium and nickel. Now here's the cool science bit. The chromium on the surface reacts with oxygen in the air to form this invisible, ultra-thin, protective layer that stops rust dead in its tracks. That's why your forks and surgical tools stay shiny and clean. Okay, you've got the theory down pat, but theory doesn't get you marks. Applying it does. So let's get into Section 3, where we're going to break down how to decode those SPM questions and turn your knowledge into points on the board. So, let's look at a classic exam question. It gives you a fact you already know. Alloy of copper is harder than pure copper. Then, it asks for the correct statement about the alloy. See? They're not just testing what you know, they're testing if you understand why.
And this is exactly where students trip up. So many people mix up the ingredients for brass and bronze. Or they'll just memorize the word harder, but have no clue how to explain it. But the biggest mistake of all is failing to connect that picture of jumbled up atoms to the real-world properties of the metal.
We're not going to make that mistake.
Here is your foolproof two-step tactic for any question like this. Step 1. In your mind, picture the foreign atoms, the zinc or tin atoms mixed in with the copper, and how they disrupt that neat structure. Step 2. Remember our core principle. That disruption prevents the layers of atoms from sliding easily. That's it. That's the answer. Every time.
If you remember just one thing from this whole explainer, make it this golden rule. Structure determines property. The way the atoms are arranged on a microscopic level directly controls how the material behaves in the real world. Get that, and you've mastered this topic.
Phew, we have covered a lot of ground. And that brings us to our final section, a little reward for all your hard work. This is it, your ultimate cheat sheet with everything you need for that last-minute revision.
And here it is, your new best friend for studying. Go ahead and pause here, take a screenshot. Notice Duralumin is mostly aluminum, making it light. Drill the difference between bronze, which is copper tin for monuments, and brass, which is copper zinc for keys. See how steel is iron carbon for buildings, while stainless adds chromium to resist corrosion. Use this table to quiz yourself. It's got everything.
So there you have it. We've gone from the tiniest atoms to giant airplanes. You have officially mastered the theory. But the next step is absolutely crucial. You have to make it stick.
Which brings us right back to where we started. The absolute best way to lock this knowledge into your brain is to use it. So head back to MCQSPM.com and start hammering out those practice questions. That's how you'll find any weak spots before the real exam.
And I'll leave you with a final thought. Now that you're armed with all this science, what's the first alloy you're going to spot in the world around you? Will it be the stainless steel spoon in your kitchen, the brass key in your pocket, or the steel frame of a building outside your window? Chemistry is everywhere. Now go out and see it.